Alright, we're going to take a look here at solving a square root equation, right? And I put up over here the basic steps for solving a square root equation. If you have an equation that involves a square root, what you want to try to do is first isolate the square root on one side of the equation, move any other numbers or variables to the other side of the equation, and then square both sides, raise both sides to the second power to eliminate that square root, and then after you do that, you can go ahead and solve for the variable. Alright, so the problem we have here that we're going to solve is 2x equals 1 minus the square root of 2 minus x. Alright, so first thing I want to do is isolate this square root. Get this by itself on one side of the equation, which means getting rid of this 1 that's here. Alright, so not too bad. All I'm going to do here is subtract 1 to the other side. So 2x minus 1 equals negative square root of 2 minus x. Right, don't forget that minus there is still attached to that square root. Now, when I say that we need to isolate the square root, I don't really need to get rid of this negative sign here, because when I square both sides of the equation, when I multiply a negative times itself, it turns into a positive. So when I square both sides, that negative is just going to disappear anyway. So it's not necessary to move that negative to the other side of the equation. You just need to get any other numbers or variables that are outside of the square root and move those to the other side of the equation. All right. So that is our first step, getting that square root by itself. And now what I need to do is square both sides. Right? Remember, squaring and square rooting are inverses of each other. They're opposites. Right? This is a square root. When I say square both sides, that doesn't mean square root both sides. Square means raised to the second power. Right? I mentioned that because I've had students in the past where I say, oh, you need to square this, and they draw the square root. Squaring is not the square root. Right? It's not like the shorter way of saying square root. This is a square root. Squaring literally means raising this side of the equation to the second power, raising this side of the equation to the second power. And the reason we do that is because the second root, which is the square root is the second root, gets canceled out by the second power. Right? So the root and the negative are going to get canceled out by that second power, and the right side of my equation is just going to be that 2 minus x. Right? So when I need to eliminate a square root, I do it by squaring both sides of the equation. Right, just like if you watched the video that I did on solving a quadratic equation using the square root method, like when I had an x squared equal to a 9, I did the square root on both sides because the square root canceled out the second power. Well, we're doing the same thing here, just the other way around. We have a square root that we want to cancel out, so we use the second power to cancel out the square root, whereas here we use the square root to cancel out the second power. Right, they're inverses of each other, so one of them always cancels out the other one. So whichever one you have, you use the other one to cancel it out. Here, since we have a square root, we use that second power to cancel it. Right, now, this side of the equation, this 2x minus 1 squared, we have to multiply that out. Remember, something in parentheses with a plus or a minus in it being squared, we don't just square the 2x and square the minus 1. Right, 2x minus 1 squared means that we have 2x minus 1 multiplied by another 2x minus 1. Right, that's what it means to square that binomial, right? That thing there that has the two terms. Right, so we'll multiply that out in the next step, and that's going to equal the stuff that was underneath the square root on the right side, which is just the 2 minus x. Right, the second power there cancels out that square root. All that's left is what's underneath. And again, that negative out front, when I do a negative times a negative, it comes out to a positive, so that negative also disappears there when I raise it to the second power. All right, on the left side now, we need to multiply this. 2x minus 1 times 2x minus 1. You can use the FOIL method to do that. 2x times 2x is going to be 4x squared. 2x times minus 1 and 2x times minus 1. It's going to be a minus 2x and a minus 2x, so that's going to be minus 4x. And then negative 1 times negative 1 is going to be a plus 1. And then still equal to that 2 minus x over on the right side. All right, so we get 4x squared minus 4x plus 1 equals 2 minus x. All right, so that is our equation. It turned into a quadratic equation. Right? We didn't start with a quadratic equation here, but now we've got an x squared, and that happens a lot when you have these square root equations. A lot of times it does turn into a quadratic, because when you square both sides, well, if there's an x on the other side and you square it, you end up with an x squared. It just happens, right? So a lot of times these square root equations do turn into quadratics. So now we have to solve this using the methods for a quadratic equation, which means either factoring it or using the quadratic formula. The square root method won't work on this one because we have this x term here. So whether I'm going to factor it or use the quadratic formula, I need everything on one side equal to 0 on the other side, which means I need to subtract this 2 over here and also add this x here. Right? So I got 4x squared, negative 4x plus 1x is going to be minus 3x. and then 1 minus 2 is going to be negative 1 equals 0. And now I have this quadratic equation that I need to solve by one of the methods appropriate for solving quadratic equations. All right, so that's where we are here. Now what I'm going to do is leave that original equation up there, but I'm going to have to erase some of this other stuff to give me room to solve this quadratic equation. All right. And if you missed any of that stuff that I just erased, you can always just rewind the video and write it down if you're taking notes on it. All right, so the quadratic equation we end up with is 4x squared minus 3x minus 1 equals 0. All right, so now I need to solve that equation. All right, so factoring is a possibility here. The numbers I have are 4, negative 3, and 1, and I can envision that maybe I can put those numbers together in a way that factors. So I might want to try factoring here. And if you don't want to try to mess with the factoring, you can just go ahead and use the quadratic formula. Remember, with a quadratic equation, you don't just add or subtract numbers to the other side and try to get the x by itself, because you don't just have an x here, you also have an x squared. Right, so you can't just try to isolate the x by just adding, subtracting, dividing. You have to use either the factoring method, the quadratic formula, or the square root method. Remember, the square root method doesn't work when we have that minus 3x. I can only do the square root method if I get x squared equal to a number, which I won't be able to get here. Right, if you don't know what I'm talking about, go back and watch the videos I did about solving quadratic equations, where I kind of went through all that stuff in a lot more detail. All right, so factoring. I'm going to try to do this one by factoring. I'm not sure if it's going to work, but it looks like it might. And like I said before, or not before in this video, but in another video, if you're able to factor something, then it's usually quicker than doing the quadratic formula. If you prefer to use the quadratic formula, you don't want to mess with factoring, go ahead and solve this one by the quadratic formula. And if I'm able to do it by factoring, they'll come out to the same answer. As long as we do our stuff correctly, the answer is going to be the same no matter which method you use. Right, but since this one has a number in front of the x squared, if I'm going to factor this, I have to use the AC method. All right, I have to multiply the 4 times the negative 1, which is going to be a negative 4. So I need two numbers that multiply to negative 4 and add to the number in the middle, which is negative 3, which that shouldn't be hard to find. Those numbers are going to be negative 4 and positive 1. Right, if I multiply negative 4 times positive 1, it equals negative 4. If I add negative 4 plus positive 1, it's going to equal negative 3. All right? Yes, good. I'm just double checking in my mind to make sure that works. All right, so those are the numbers I need. Now remember, for the AC method, and if you don't remember how to do this, I did a video on factoring using this AC method, so you can go look for that one and watch it. But when I get those two numbers, I split apart this term in the middle. So I copy down the 4x squared, right? That minus 3x, I split into a minus 4x and a plus 1x, and then I copy down that minus 1 that was at the end there. All right, so the two numbers I find I use to split apart my middle term, and then I use factoring by grouping. Right, so I split this into two groups, and then I do a common factor from each group. So 4x squared minus 4x, well, those two have a 4x in common, right, which leaves me with just an x here and just a minus 1 there. And then for the next one, I have a 1x minus 1. Well, the only thing they really have in common is a 1. And when you're doing this, this factor by grouping method, you have to pull something out. So if they don't have anything in common, you just put a 1 outside, which leaves me with an x minus 1. And then all this still equal to 0. And remember, the key thing when you're doing that grouping method is that those parentheses have to be exactly the same, which they are, which means that this is going to work. Right? If I can't get those two parentheses to be exactly the same, it means I wouldn't be able to factor this. Right? But since they are the same, I know that factoring is going to work, and I'm actually almost there. Right, so that x minus 1 is one of my factors, and then the stuff that I pulled out, the 4x and the plus 1, that makes up my second factor. Right, that's why I said you have to pull something out of this parentheses, because you need something to put in that second factor there. So if there's nothing that they have in common, you still have to put that 1 there so that it ends up in that second factor. All right, so I get x minus 1 times 4x plus 1 equals 0. All right, now what I need to do is finish solving this equation. So remember, the zero product property when you're factoring says if I have two things multiply that equals 0, that means either x minus 1 equals 0 or the 4x plus 1 equals 0. One of those two things has to equal 0 in order for them to multiply together to equal 0. So for this one, x minus 1 equals 0. If I add the 1 to the other side, I get x equals 1. And for the 4x plus 1 equals 0, if I subtract the 1 and then divide by 4, I'm going to get x equals negative 1/4. All I'm just looking to see. Yeah, that's just on the bottom of the screen there. Good. All right, so I get two solutions to this quadratic equation, x equals 1 and x equals negative 1/4. All right, now notice I didn't put a big circle around those answers because one of those may be an extraneous solution. Right, if you watch the video that I did on the fractional equation or the equation with fractional expressions, anytime you're solving an equation that doesn't start out as a quadratic equation, right, and this original equation that we had with a square root in it, that was not a quadratic equation, right? It did not have an x squared. But if, through the process of solving that equation, it turns into a quadratic equation, and then that quadratic equation gives you two solutions, you need to check those solutions because these two here, x equals 1 and x equals negative 1/4, those are the solutions to this 4x squared minus 3x minus 1 equals 0. They're not necessarily solutions to that original equation that we started with, right? Anytime your problem or your equation turns into a quadratic and it didn't start that way, you need to double check your answers. So I'm going to write the answers up here. X equals 1, x equals negative 1/4. All right, so those are my two solutions I got from my quadratic equation. And you don't want to check those in the quadratic equation that was up there that I just erased. You want to check those back in the original equation that you started with, the one in this case that involved that square root. Right, so now I need to check for the extraneous solutions. Maybe both of these work and they both solve this equation. Maybe only one of them works. Maybe neither one works, right? So we have to check them both to see whether or not they actually solve the equation. Right, so if I start with x equals 1, right, so I have 2 times 1 and I want to know, is that equal to, so I put that little question mark above the equal sign, is that equal to 1 minus the square root of 2 minus 1? So let's say, well, the left side is pretty easy. 2 times 1 equals 2. And I want to know, is 2 equal to 1 minus the square root of 2 minus 1? 2 minus 1 is 1, right? So it's 1 minus the square root of 1. Now, the square root of 1 is 1, and 2 does not equal 1 minus 1, right? 1 minus 1 is 0. So I can see, and you might have been able to see way up here, well, that's not going to equal 2. As soon as you see that it's not equal, you can just stop and say, well, this side does not equal that side. Therefore, x equals 1 is not a solution to this equation. That is what we call an extraneous solution, right? It's an extra solution. It solved that quadratic equation that we ended up with, but it does not solve that original equation. That's why we need to check our answers, right? Because if you say, well, these are the two solutions to this equation, that's not right, right? Because x equals 1, as we just saw, doesn't actually solve the equation. It doesn't make the two sides equal to each other. All right, so now we have to try x equals negative 1/4. We can't just assume because the first one didn't work that the second one will work. Sometimes, neither one of them will work. So you do have to check them both. All right, so now I check my other one. So it's 2 times negative 1/4 equals 1 minus the square root of 2 minus negative 1/4. Right, and we want to check whether or not that's equal. So I put a little question mark there. And if you want to just put this into the calculator to see what each side is equal to, by all means, go ahead and do that. 2 times negative 1/4 is going to be negative 1/2. And I want to check if that's equal to 1 minus the square root of 2 minus 1/4. That's going to be 2 plus 1/4. That's 8/4 plus 1/4. So that's going to be 9/4. All right, and I'm just working through this quickly just to see if this works out. If you need to take more time and think about it and find your common denominators and all that stuff, go ahead and do all that. So yeah, negative 1/2, is that equal to 1 minus, and then the square root of 9/4 is going to be 3/2, right? The square root of 9 is 3, the square root of 4 is 2, and then 1 minus 3/2 is going to be 1 minus 1/2 is going to be negative 1/2. Right, so it turns out that the two sides here are equal to each other. So x equals negative 1/4 is a valid solution to this equation, right? And like I said, when you're checking these, you can, if you want to, just put this side of the equation in the calculator, put that side in the calculator. You'll get negative 0.5 and negative 0.5. When they come out the same, you know that your solution works. If they come out different, like they did over here, you know it doesn't work. All right, so again, really important. Well, when you're solving a square root equation, get the square root by itself. Raise both sides to the second power to cancel the square root out, and then solve the equation. A lot of times that will turn into a quadratic equation, so when you get your two solutions, make sure you plug them back into the original to check to see if you have an extraneous solution. It's one of those things that students all the time kind of forget to do. You think, well, I got through all this problem, I got my two solutions, I'm done, let me move on to something else. But remember, if it doesn't start as quadratic and it turns into a quadratic equation, you're probably going to have an extraneous solution. You need to check which one works and which one doesn't.